Now for 11. Bug travels a tree. 30 seconds. Travels fast. Slows down. Stops for 10 seconds. And proceeds slowly. Speeding up. So basically, the bug first goes fast. Starts to slow down, so the slope's not as strong. And then stops, which means you have no slope. And then proceeds to go slowly. And then it starts to go faster. So you break this up into 5 different parts. Now A is consistent, B is negative, C fits it the most, and D is negative as well. Now I'm being chased by a clown. 6 ms for 10 seconds. Tripped. Face plants into the ground. Clown is a constant speed. Now I begin to crawl at 2 ms for 10 seconds. Afterwards, due to an injury, I am now at 1 ms for 4 seconds. And that's the enemy. Shouldn't know how to use that question. Best graph. You have meter seconds in multiple locations of the story. So most likely a VT graph. The slope of this line is usually acceleration. If an object is thrown into the air at an angle, what is the relative to the ground surface? So here's your ground. Here is a right degree angle. In this case, we do not. So let's say it's about 45, 60. Objects thrown. And it will most likely fall back into the ground. Now we start in the center. We do not end in the center. If acceleration is negative, which the fall can be expected graphically. Keyword. 2 ways to interpret this. First one is a VT graph. If you recall, the slope is acceleration. So acceleration will be downwards. Another way, in a negative acceleration, you have an AT graph. You have quadrants 1 and 4. If you recall, quadrant 1 is positive, quadrant 4 is negative. So your slope would exist somewhere in quadrant 4. It doesn't necessarily have to go down, but it will exist. In this case, you have negative, and in this case, you still have a negative acceleration. 16, similar to 14. You have the ground, 90-degree angle. If it's thrown completely up, it will return right back down where it originated. For 17, acceleration positive. This means that final velocity will be greater than initial over a certain segment of time. Now, your y-axis is ms squared. Your x is time. Here's your graph. You have acceleration over time. This is an AT graph.